In this lecture, we start chapter 3, the derivative, and we start with 3.1 limits. We study them numerically and graphically. So let's start with limits. What do we mean by limit? If I give you a function like f of x equals 1 over x minus 1, and I ask you to find f of 2, you say 1 over 2 minus 1, that's 1 over 1, which is equal to 1. All what you need to do is to plug the value of that you want to find the image for it. So f of 2 gives 1, and that's our answer. Now if I ask you to find f of negative 1, you just plug negative 1 here. So you get 1 over negative 2, which is negative 1/2, or negative 0.5. But what if I ask you to find f of 1? When I ask you to find f of 1, you just plug 1, but you get 1 over 0, and this is undefined. This is undefined in mathematics. We can't allow for 0 to be in the denominator. But what should we do in this case? Can we just say it's undefined and that's it? Actually, in some applications, we need to say something about that value, at least to approximate that value. If we don't know it, or if it's impossible to find the value of the function at some value or some point, we need at least to approximate that value. That's algebraically. Also, if we have a graph of a function like this, and I ask you to find f of 1. You can't find f of 1 because you say that we don't have an image. We don't have a corresponding value for 1 because there is a hole here. But what about 1/2? For 1/2 you can find an image. This is the image. So this is the value here. So what should we do in this case? In this case, we can approximate 1. We can choose some value that's very close to 1 from the right, some value that's very close to 1 from the left, and see if they approach some value. If they approach some value here, then that's the limit. The limit is just approximation of the value of the function. That's the idea. We can't find the image or the value at a specific point, and we want to estimate that value or approximate it using limit. Now, how to use limit? We use the following notation. We can write limit of the function f of x as x, for example, here approach 1. What does that mean? That means x is not equal to 1, but x is very close to 1 from the left, from the right, and from the left. We may choose 1.00001. This is very close to 1 from the right. Or we can choose 0.99999. That's very close to 1 from the left. So we can find the images of those close values to 1, and that should be a good approximation of the value of the function at that impossible, or that value that, I mean, the function is impossible or not defined at that value. So this is what we mean by limit. And so in general, we write x approaches a, and we read limit of the function f of x as x approaches a. Now, how to find the limit? Let's first take a simple example. F of x equals 2 plus x. We know that this function doesn't have any problem. We don't have any point that's impossible to be evaluated. So, but this is just an example to show you how limits work and how can we find limits. Okay. Now, for this function, if I ask you to find f of 3, then you just plug 3 here and you say 2 plus 3, that's 5, and that's it, because we don't have any problem with this function. And as I mentioned, the reason why I introduced this function is just to study the limit using simple function, but not this here limit doesn't have that importance here, practical importance for this example. Okay, so f of x equals 2 plus x. We want to find the limit as the limit of the function as x approaches 3. Now to find the limit, we choose some values that are greater than 3 but very close to it. For example, 3.0001, 3.001, 3.01, and 3.1. You can choose those values that are very close to x from the right. So x, those are x values that are approach 3 from the right. And similarly, you can choose values that are very close to 3 from the left, like 2.9999, 2.999, 2.99, and 2.9. Those are values of x. Now we find the corresponding value of y or f of x. We just plug them here and find the corresponding values. For example, when we plug 2.9, we get 4.9. When we plug 2.99, we get 4.99, and so on, and we get these values. Similarly, from the right hand side, if we plug 3.1, we get 5.1. If we plug 3.01, we get 5.01, and so on. So if we look at the second row, we find that as x approaches 3 from the left, what happens to the values of the function? They approach 5. And what happens as x values approach 3 from the right? The images, the values here approach 5 from the right. So the limit is equal to 5. And that's how we find limit numerically. We take some values that are greater than the limit, the specific value that we study, and some values less, and then we see if they approach some specific value. So we write here limit of 2 plus x, the function, as x approaches 3 equals 5, and it's read limit of the function f of x equals 2 plus x as x approaches 3, the value 3. Let's take another example. Now for this example, if we want to find the limit using tables or numerically. As you can see, if we plug 2, we get 2 cubed minus 8, 0. 2 over minus 2 is 0. We get 0 over 0, but 0 over 0 is undeterminate form. So this is not a number. We need to find this limit. How to find this limit? We put the limit value here in the middle. I mean, x approaches 2, so we put 2 in the middle, and we choose some values greater than 2, as you can see, but very close to 2 from the right, and some values less than 2, but very close to it from the left. And then we plug them into the function. We don't have any problem with these values because they are defined. We only have a problem when x is 2, because that brings 0 over 0 form, and that's undefined, that's undeterminate form. So we find, for example, we plug 1.9. You can use the calculator to get 11.41, and then plug 1.99, plug all these values. As x approaches 2 from the left, what happens to the values here? As you can see, 11.41, 11.4901, 11.9940, 11.9994, and then we are approaching 12, as you can see, from the left. What happens from the right? As x approaches 2 from the right, we can see that the values approach 12 from the right. So this is the limit. So mathematically, limit of the function as x approaches a is equal to L some number. In this case, it's 12. So this is the numerical approach to find limit. If there's no such L, if it's from the right, it's different from the left, the value of the functions, I mean, if, for example, if from the right we get 7 and from the left we get values that are very close to 12, those are not equal. That means limit does not exist. And we use the abbreviation DNE. in that case. So the first step to find the limit is the direct substitution. We just substitute the value of the limit. For example, here x approaches 2, we just substitute 2 and see if we got some value, like in the first example, if we get some value like if we get some value like 5 by just direct substitution, that's it. That's the value of the limit. But if we get 0 over 0, for example, like this one, we need to look for other methods or ways to find the limit, as we did in the previous example using the numerical method. So this is the first step. Now, for example, if we want to find limit of square root x plus 3 as x approaches 3, we can plug 0 here, even though x does not equal to 0, but the function doesn't have any problem with that value. It's still defined, so we can substitute that value. We get 0 plus 3, that's square root 3. That's the value of the limit. What about the second problem? We have 1 over 0, and that means limit does not exist. Why? Because if you choose some values greater than 2, if I make a table here we have 2, and this is x, this is f of x. If you choose some values greater than 2, let's choose 2.01 and 2.1, and less than 2, 1.99 and 1.9. And you can use the calculator to find this. You find that those values here get bigger and those get smaller and smaller because they give negative. For example, if you substitute 1.9, you get 1 over 1.9 minus 2, and that's 1 over negative 0.1. But this is 1 over negative 1/10, and then take reciprocal, you get negative 10. So this is negative 10. Now what about 1.99? You get 1 over 1.99 minus 2, and that's 1 over negative 0.01, which is 1 over negative 1 over 100, and that's negative 100. As you can see, as we approach 2 from the left, what happens to the value? The value gets very bigger and bigger, but with negative sign, and that means approaches negative infinity. And from the right, if we substitute 2.01, we have 1 over 2.01 minus 2, and that's 1 over 0.01, which is 1 over 1/10. This gives 10. And when you plug 2.1, you get 1 over 0.1. Yeah, this is 10. This is 100. This should be 100. Okay, and as you can see, if we add more zeros after the decimal place here, we get the value the value gets bigger and bigger in the positive direction. That means we are approaching, as x approaches 2 from the right, we are approaching infinity. As you can see, the left hand side is not equal to the right hand side. That means limit does not exist. Now, finding the limit graphically, that was the numerical approach to find the limit. Now, graphically, how to find the limit. So look at the graph below. Here, the value of a is 2. So let me write it here. Let me write 2 here and here. Now, what is the value? What is limit of x as x approaches 2? When x approaches 2, look at 2. This is x2. When x approaches 2 from the left, what happens to the value of the function? The value of the function approaches, this is 2, this is 4. Approaches 4, the height is 4. So from the left, x approaches 2 from the left. When I put negative sign here, that means from the left is 4. What about limit of the function as x approaches 2 from the right? I write positive above the number 2. Now from the right here, as x approaches this, what happens to the function? The function approaches the height 4 as well. So since the left hand side is equal to the right hand side, then the limit is equal to 4. Now, what about limit of the function as x approaches -2? This is -2. Now, from the right, as x approaches -2 from the right, as you can see, the value of the function approaches 2. So limit of the function as x approaches -2 from the right is 2. And limit of the function as x approaches -2 from the left, that means here. Let me use green color to make it easier to follow what I write. From the left, that means the function approaches, you look at the image of this piece, so the function is approaching 2 as well. And those are equal, that means the limit is equal to 2. So to find the limit, we need to find it from the left and from the right. Now, what about limit of f of x as x approaches infinity? When x approaches infinity, as you can see here, x approaches infinity, what happens to the value of the function? The function gets closer and closer to the x-axis, and the height of the x-axis is 0. So we can write 0 here. So we conclude that the limit f of x as x approaches a is equal to L. That means exists, L some number. In these examples, that was 4 here, 2 and 0. These are values of L. This is exists if and only if the limit from the right hand side is equal to the limit from the left hand side. And limits do exist. Let's take another example. We want to use the graph, and we have same thing here. The a means 2. So we want to find limit of the function as x approaches 6. Where is 6? X approaches 6. This is only defined. Okay, so let me change this into 5 to make it easier to study this. 5 is here. This is 4. This is 5. Now, limit from the right is approaching 1. That's the height. So from the right is 1, and from the left is approaching 1 as well. So the limit is 1. What about limit of f of x as x approaches 2 from the right? Just one-sided limit. This is called one-sided limit. From the right, x approaches 2 from the right. What happens to the images? They approach this point, this height from the right, but this is -2. So the answer is -2. What about this? Limit of the function as x approaches 2 from the left. Let's use different color. 2 from the left, that means here. What happens to the graph? The graph approaches the height -2 as well. And as we can see, since the limit from the right, x approaches 2 from the right, is equal to the limit of the function as x approaches 2 from the left, those are equal, then the limit, we don't need to determine left or right, because this means left and right is equal to -2. Let's do another problem. We have this graph, and a is 2 as well, so I'm going to change this into 2. Now we want to find limit of the function as x approaches -2. X approaches -2, this is -2. From the right, as you can see, the graph approaches this height, which is -2. So from the right, -2. Now from the left, I'm going to use the green color. From the left, the image or the height of the function approaches -2 as well. So those are equal. That means the limit is equal to -2. Now what about limit of the function as x approaches 0 from the right? 0 from the right. This is 0 from the right. As x approaches 0 from the right, what happens to the images? They approach this point here, but this point is -6. What about this? Limit of the function as x approaches -infinity. Negative infinity here. this is negative infinity. This is x approaches negative infinity. And as you can see, the line, the curve approaching that the x-axis but doesn't touch. So what is the limit in this case? The limit is 0 because the height of the function approaches 0. As you can see, it gets very closer and closer to the x-axis, and the height of the x-axis is 0. Now what is f of 0 without limits? The image of 0 is here. It's 4. But it's not here because here it's open.